Hello everyone, this is Sai Verma, and this presentation is all about MLOps and DevOps, like things to consider to develop an infrastructure, to deploy the ML projects, and how data makes a difference in developing, and how ML stack is developing. All these things are covered. We have seen that DevOps has an infrastructure with well-defined processes, modern tooling, and automatic workflows. In this presentation, we see why ML needs a special treatment in the first place, and what does a modern technological stack for a streamlined ML processes look like, and how can we start applying this stack in practice today. In normal non-ML applications, we have well-defined, narrowly scoped inputs, like with which the engineering can cleanly model the code. But in contrast to that, ML has like a complex, messy data, real world data, which is too complex to understand, and it cannot be modeled by hand. Now let us look into the ML application requirements. There are like many applications ranging from email spam filter to self-driving cars. ML application needs to be developed through cycles of experimentations. Due to the constant exposure of data, we don't learn the behavior of machine learning apps through logical reasoning. So what are the requirements? One should keep in mind ML applications are directly exposed to the constant changing real world data in contrast to that of the non-ML applications. The tools that we use to build ML applications are insular, that is good for prototyping, but they are lacking when it comes to the production use. So here we need a path that allows the results of these data-centric models and data-centric applications in general to be deployed to the modern production infrastructure. Similar to how the DevOps allows traditional software artifacts to be deployed to production continuously and reliably. The new path is analogous but not equal to that of the DevOps path. Now, this is how the modern stack of ML infrastructures look like. It is believed to contain the best parts of modern production infrastructure to ensure robust deployments, as well as draw inspiration from the data-centric programming to maximum productivity in use. So this is how the stack look like. The image given below gives a clear picture of enormous number of modern ML tools that are used in different layers of a modern stack. All these tools or softwares have important functionalities of their own and must be used in a proper way at each layer of the modern stack. Now let's look into the foundational infrastructure layer. Data, commute, orchestration are three main components of foundational infrastructure layer. Data being the core of ML project, where most of the data is stored in closed pair warehouses like cloud-based warehouses like Snowflake's RDS Aurora. To make data useful, we must be able to conduct large-scale commute easily. Coming to the orchestration, we must be able to manage the complexity of applications by structuring them like a graph or a workflow that is orchestrated. Is a popular open source workflow orchestra. Argo, a new orchestra that runs natively on Kubernetes, and also managed solutions such as Google Cloud Composer and AWS Step Functions. ML applications and software artifacts exist and evolve in a dynamic environment. To manage this dynamism, we need a strong versioning layer. Git and GitHub are one of the most popular ones, but they are a bit clunky for tracking all the experiments, models, and data. To plug this gap, frameworks like Metaflow and MLflow provide a custom solution for versioning. We know that Python is one of the most preferable for ML. Python written in Jupyter notebooks following the tradition is very different from that of Python written in implemented in scalable web server. To make the data scientist more maximally productive, we must provide supporting software architecture in terms of APIs and libraries that allows them to focus on data, not on the machines. With these five layers that we spoke about, we can present a highly productive data-centric software interface that enables interactive development of large-scale data-intensive applications. However, none of these layers help with modeling and optimization, which is done in data science layer. For model operations in science layers, there are many new tools with various aspects of operations, including Sheldon for model deployments, weights and biases for model monitoring, and True Era for model explainability. Before you have a model, you have to decide how to feed it with labeled data. Managing the process of converting raw facts to features is a deep tonic of its own. There's an emerging space of ML-focused feature stores such as Tectron or labeling solutions like Scale and Snorkel. Finally, at the very top of the stack, we get to the question of mathematical model, like what architecture or model is to be used. For this job, we have excellent libraries like scikit-learn or PyTorch that are available to help with the model development. Testing. Regardless of the systems we use at each layer of the stack, we want to guarantee the correctness of results. In traditional software engineering, we can do this by writing tests, but this is not possible when the model is opaque to us. Black box and A/B testing are one such testing processes to be conducted on these types of models. Wrapping the stack for maximum usability. Many data-centric environments of the previous generation, such as Excel or Studio, really shine at maximum usability and developer productivity. Optimally, we could wrap the production-grade infrastructure such as Snowflake, Kubernetes for each layer of this stack inside a developer-oriented user interface. The combination of a production-grade core and a user-friendly shell makes sure that ML applications can be prototyped rapidly. For the past 5 years, a number of such frameworks have started to emerge, both as commercial offerings as well as in open source, where Metaflow is one such example. Finally, Metaflow integrates with best-of-the-breed production infrastructure such as Kubernetes and AWS step functions, while providing a development experience that draws inspiration from data-centric programming. Google's open source Kubernetes addresses the same Kubeflow addresses the same concern. Thank you.